directorate, but those who have astronomy background to understand why we call ourselves even it is a opportunity network. So we're still looking for a new name for that. So just a little bit about our background. We are tasked with developing astronomy in Botswana. That includes tool research, HCD, and outreach.
Yeah, I think
you want to show?
Yeah. How do you do the slide show from there? You should have part of this one. Yeah. Anyway, what happens when you don't use Windows on and change the video to full screen? Yeah. So, why is the view of the player full screen? Oh, wait. Is it two different screens? Or?
Yeah, I think you should use that screen.
Okay, I'll do that now, but I want to first get the shortcut again. Shortcut is Control L. Okay. So we have to close this one first, I guess.
Yeah,
is it?
Yeah, do the same thing using that one.
Ooh, can I do the same thing again?
Yeah.
There we go. Yeah, there we go.
Thank you. Okay, I was still saying we are responsible for development of astronomy within Botswana. And we have like different initiatives. Some of them, they've already mentioned them. So we do outreaches, we do some robotics, astrotourism, and those are some of the pictures from our different projects. And Hackathon falls under our mandate. So the group, I have like a team of many people, but I will just mention a few here. So I'm the team leader, and recently I protected Dr. Zibweni, the second guy. So he's from computer science. And while I was just going around realized is the one guy who's doing this kind of projects, the hackathons and the robotics. So I had to include him in my team. Then I have Dr. Mukupiki and Dr. Paisida from the same directorate as mine, an engineer and a computer scientist. Then there's another guy here. I don't have his picture at the moment. So he's from the BOTSAT team. BOTSAT means Botswana Satellite. So I thought this year's hackathon will be a valuable member. So I had to include him in our team. So we have run the hackathon last year. So that's the image from our previous hackathon. So overall, I would say we got a positive feedback from participants. We're very excited. And some of them, they were part of the conference hackathon. So I had there were like 4 guys from our hackathon that they've attended the conference hackathon. So the conference hackathon, anyway, we hosted a first conference everyone. So there was a Hack4dev conference that some of the students they attended. That means now you found this most exciting, and they managed to register for the hackathon for the conference. So challenges, I think if you mentioned a few challenges that I came across when I was organizing this, that include the shortlisting that we have discussed, getting a suitable date. So it's very important to get a suitable date when the students are not going to classes. Because like I said, someone will register from the different university, then they just miss classes saying, I'm attending a hackathon. Then you will have a problem with the university, with other universities. So then there's few university protocols that someone already mentioned. You have to go through some stressful writing letters saying, justifying why you should host this. But overall, we've managed to host a successful hackathon. And the objective is to make this initiative grow to a point where we can be able to raise funds. For example, if I don't get the funding for next year, I should be able to maybe fund myself so that I can continue with this initiative. So thank you.
Jerry, could you please just kindly show me where your presentation is and then it's titled? Yeah.
Good afternoon, everyone. So my name is Jared Mbiro from Masai Mara University. This is one of the regions in the southeast of Kenya, and we hope to host the regional hackathon at Masai Mara University. We will propose a date of 28th September to 1st October. But we also give other dates due to the logistics. So in this region, we hope to bring around 5 universities. And this is Kisi University, Chuka University, Masai Mara, Egerton, and Multimedia. So these are the team members. I am the lead team. Then we have other team members from these various universities. Dr. Spara Mutui from Chuka, Dr. Nico Eba from Egerton, Dr. Dennis Ombati from Kisi, then Dr. David Wakura from Multimedia, and Dr. Joel B from Masai Mara, Dr. Hemwa from Masai Mara, Dr. Benedict Trun from Masai Mara, Dr. Bakari Chaka from Masai Mara, and Madam Abby Christine from Masai Mara. So some of the team members here, they have from computer science and physics, and also from chemistry. So it is a wide range of expertise. So the expectation from this hackathon is to build capacity in our various universities through this training, and also to try to solve our societal challenges in Kenya, and also in particular in the East Africa region. So we look forward for skill development by equipping the students with data coding skills, teamwork, and project pitching techniques. Then we look forward for networking opportunities, as we will be able to bring on board various students. We look forward for them to network. We mentor them, train them, and also link with industrial partners. What will our universities benefit is visibility and recognition as centers of excellence in matters innovation. So thank you.
Hello everyone. I'm Latte Collins. I am a PhD student in computational physics. I'm from Ghana, and we are posting our system from the University in the Ashanti region. These are my team members. Steven is a PhD in computer science, and he's working on AI in application in geophysics, and then Jemima and Ferguson are also in MPhil astronomy. And then KNUC is a prominent university in Ghana in the Ashanti region. And then there are a host of venues there. So we are hoping that the tentative date will come out and then we can get a potential venue, because most of the venues are used for other things at different times in the year. So we'll get a tentative one, then we can use a suitable venue, which is free. And then we expect that the participants will be able to move their skills in the school out into applying to practical problems in the environment and the region. Thank you.
Just going to download it.
Okay.
Yeah, I did.
Okay. Is it coming?
Gonna show you.
Yeah, there you go. And full screen control L, I think. So, what's that? Oh no. Oh, there you go.
Takes time to take the, yeah.
Hello everyone. As they say in my country, my own. So I'm Anthony. I'm the team lead of one of the regional hackathon team in Madagascar. So my team is composed of 5 people. So there is myself, and then we have Manch for the logistics, Tik for managing the finances, we have our reference in data science, and Kensu for everything regarding communication. So our initial dates were expected to be on the 16th to the 19th of September. And so we plan to do it at the Orange Digital Center, which is a training center for tech. And so our objectives were to have 30 people, and having an emphasis, putting an emphasis in diversity, especially in the number of universities involved and the profiles, such as last year where we had professors, not only students, but professors, professionals, and that's what we are trying to bring back this year. Apart from that, of course, equality between the genders and the networking with the professionals. So we are planning to invite professionals from tech companies to assist to the event. And so that's it. Thank you.
Good afternoon, everyone. I am Jean-Marie John from United Methodist University of Mozambique. I'm the team leader of the Hackathon, but our team composed with Cecilia Tizir from Hack4dev University, Dakar, Senegal, Richard Evans from United Methodist University of Mozambique, Eunice de Lampunos, also from United Methodist University of Mozambique, Logat Mohammed from UCM, Catholic University of Mozambique, and Maria Pedro, also from UCS. Okay, we are planning to organize the event at Catholic University of Mozambique, in central part of my country, Mozambique, in Manica province. And what we hope to achieve is skill development, research innovation, and community building. We are willing to equip students in a professional with hand on data science, Python, AI skills through intensive project-based learning. Also, to accelerate innovation in data science and social science by solving real-world local challenges with data-driven, and also faster thriving network of emerging data scientists in Mozambique, connecting students, mentors, and professionals. Thank you.
Good afternoon, everyone. My name is Lynn Mambalakata. I'm coming from the University of Zambia. At the moment, the team comprises of 2 people, Gift Sichone and myself. But unfortunately, Gift Sichone is not here with us because he's overseeing the DARA program that just started at the University of Zambia today. So yeah, so it's just me for now, right now. So initially, we planned on having the hackathon from the week starting July 28th, but after today, yeah, I see that we'll have to revise those dates now. So the hackathon is scheduled to be at the University of Zambia. The date is yet to be communicated. So what we hope to achieve with this hackathon? This hackathon will target postgraduate students and final year undergraduate students, not only limited to students, but also young professionals in STEM, and of course, it's open to other fields as well. But hopefully, these people will be equipped with data analysis skills, programming, and visualization, which will help them when it comes to making data-driven decisions. Thank you.
Good afternoon. My name is Naomi Nagwimba. I am also from Zambia, the Copper Belt University, the only university in Zambia. I'm the team lead for for our team, and we'll host our hackathon at the Copperbelt University. On our team, we have Dr. So, Dr. Alok, Jackson, and Tawana. And what we hope to achieve. So we hope to provide value through innovation and problem solving, drive creativity and skills development and collaborations, and also enhance visibility for Copperbelt University. Very brief. Thank you.
Hello everyone. My name is Kepa Kinori from University of Nairobi. So yeah, it's been a journey with Hack4dev. I first got introduced to Hack4dev in 2023, where I was a participant in the African Astronomical Society Hackathon in 2023, where we won the hackathon that time. And then I participated in the first cohort for the Data Trainers Hackathon in 2024. So yeah, we achieved significant participation. That's what we got last time. We had around 120 applicants, selected about 24, and 14 turned up. Yeah, so we are hoping to build on the success of the previous hackathon in the upcoming 2026 Data Regional Science Hackathon. Yeah, so our vision and goal is to continue bridging the gap between theoretical data science training with real-world problem solving. As like the first problem we had. So the people behind the team, so this is still the same team which organized the first hackathon. We got me as the first the lead organizer. So I'm a software engineer, but it's a hybrid team, mainly consisting of professionals and one scholar. So for me, I'm a software engineer with specializing in backend development. We've got Melissa Michuki, who is my deputy, and she's a trainer at Go My Show. The other is a senior data engineer at Greenpeace, and we've got a risk analyst amongst our team, and an MSc student who was part of the previous data science regional hackathon. So yeah, one vision is growing the community. We've got so as part of the success of the team, we've got an addition to the team of the who is Kevin Obote, team member number 5. He was part of the winning team in our regional hackathon. And a separate team, we've got Enoch Zioka, who is leading a separate hackathon in Kenya. Yeah, so look ahead to go in the next round.
Various slides, right? We'll take time to the actual screen.
Hi everyone, I am Sandra. I am from Madagascar and I am representing the organizers of Feneratsu Regional Hackathon. Our team is composed entirely of women. Eve, Eve is our team lead and freshly graduated from ENI. I am Sandra. I am the logistics manager. Also graduated from ENI. Count our treasurer, still a master student at ENI, and from GIT, we have Tiar as communication lead and Jen as technical lead. Together we are ready to run this event. The hackathon will be hosted at Madagascar, a digital services company in Feneratsu. The venue is confirmed and supported by the owner, who is also one of our professors at University ENI. Why? Because it offers the perfect environment for a 4-day intensive sprint, a spacious room for 30 participants, high-speed internet connection, stable electricity, and all the necessary amenities. Four of us participated in the last hackathon last year in Antananarivo, and it was a really great opportunity. So right now, tech opportunities are always concentrated in the capital. We want to bring this hackathon to Feneratsu to give local students the same chance to learn, apply the pattern to real problems, and shine internationally. Our goal is to make this hackathon an annual milestone that permanently strengthens our regional tech ecosystem. So thank you.
So is it yours going to be giving? You can just come through, please. You say you saw it, right?
Yes. Yeah. I think it's titled stats keys on the thing. I saw it.
This one.
Yeah.
It's so beautiful.
Hi, everyone. So we're the Stats Geek Society from the University of Cape Town, and our mission is generally to focus on bridging like the gap between the theory that we learn in the classroom as to the real world applications. And so far, we have tried to achieve it through panel discussions, industry talks, as well as exposing students to career opportunities and showing them diverse career paths. And this is the team behind Stats Geeks. Not as impressive as an all-woman team, but I think it's pretty good. Yeah, and we have always wanted to host a hackathon because, as like the earlier presentation said, it's like an opportunity to actually apply the skills that you learn, but also explore something that's like outside the classroom, and the students get to research that. So with our goals with this hackathon is to host a platform for students to problem solve and also to facilitate technical upskilling, as well as show like the real world impact of what they're learning, because sometimes it's hard to see like how this can be used in real life. And where we'll be hosting it is upper campus, some lecture theatre there on upper campus. So yeah, thank you everyone.
I'm sorry, guys, I'm just trying to find some of the presentations, but I know Musima in the next. You can just stand up so long while I'm trying to locate your presentation.
Colleagues, I'm a civil center. I just wrote a PhD in computer science. I'm representing Sipako Health Science University. So this is the organizing team from SMU. We've got Kazisa Mkhonomoto. She's a technical and marketing leader. And then we've got Fikile Mokola. She's a logistics and sponsorship coordinator. We do have Tsolofelo Sugome, who she's organizing our food and mentorship coordinator. We have Orandile Mashama, he's our IT and technical lead. And not only them, we have our bigger team of the organizing committee. We have Professor Tony Mkolo, we have Dr. Narato Wiyama, we have Mr. Siamonga Masuko, Dr. Raikani Sareto, and Ms. Naledi Matole. So, like I initially said, our institution is based on healthcare. So, our management don't promote anything that is not talking to health sciences. So, but when we review this, we just find that parents will phrase our feeling to looking on how can we use data science to build resilience features focused on responsible AI for planetary health and community safety, which we think it will be acceptable on the approval process. We are hoping to host it at Sefako Mahato Health Science University in our sports complex. It has everything. We've got showers, we've got, even the gymming facilities. So your most welcome. We'll give you the sponge to sleep over. Because our university calendar is too tight, we really have to stick to what they put on the table. So we're looking at hosting our hackathon from the 2nd of September to the 5th, which is overlapping on a Saturday. So simply because we've got limited resources, we are hoping that the first day it will be online. It will be half a day online, and then from Thursday it will be physically, and Friday and Saturday. Simply because we don't have enough laboratories and open on schedule. So yeah, this is what we are hoping to come. Okay, this will be our first hackathon, physically, focusing on data science, and we are hoping everything will work out. And I just want to say I am an alumni from Dara and Sarau. I attended the hackathon previously on Big Data Africa, so that's where I really got inspired, and I'm hoping this will also increase the network, like take it out to influence others into this field. Thank you.
Good afternoon, everyone. My name is Emma Bioka. I am a robotics and software engineer. So I'm here representing Team Seco, which is in the southern part of Kenya. So it's not my first time here, like in a hackathon. So I was introduced to Hack4dev last year. I was at University of Nairobi. I was one of the participants in the hackathon last year. And we managed to become position 3, but we had the best solution. So that was quite an achievement. Yeah. So when applying, and again, when applying, I was very appreciative of the efforts that CEPAS helped. So on the location, so Seku is located in the southern region of Kenya, and it's located very strategically because, first of all, it's going to help accommodate students from that region because it's almost 200 kilometers from Nairobi, meaning it's quite interior according to the location. Again, on the heritage, so if you don't know, Africa they have, like, our ancestors have been practicing astronomy from before even 300 BC in the likes of Morotunga, which is located in the northern regions of Kenya. That's the oldest calendar that you can find in the world. So that's something you should know. So this hackathon will make the students, first of all, learn of their ancestry. So learn on how astronomy is used to solve different problems that they have in the current world. So again, Seku will help in being an innovation hub for this. It helps a lot in giving us, first of all, a location to host this. This is my previous institution, and with that, let's meet the team. So that's me, again, Enoch. I am a robotics engineer, and I'm also an innovator. First of all, I'm a founder. I founded AgroBoots Africa where we majorly deal with robotics for agriculture. We use robotics, AI, machine learning, and satellite imagery to tell farmers on what to plant and when to plant and how to plant it, and also the robotics bit of it for automation. Again, I'm the CTO for both Founders House and Credit, and I'm also the Global Ambassador for Kenya at the GCRAI, that is the Global Council for AI. On the side, I am a coding and robotics trainer and coordinator at Bartech, and I'm an application support engineer. The USSD, the star something hash. In different countries, we manage that. So that's Shifra. Shifra is our second member. She is very big in AI advocacy. She's the president for GCR AI, representing Kenya. And she runs Founders House. She's the executive director, the founder. And she has mentored over 300 students, majorly women. And in 2025, she won the Women Tech Network Leader of the Year. And that was quite amazing. We have Shalmin. So Shalmin is quite huge in DevOps and also the operational side of things, and also in cybersecurity. She'll help us in making this event run quite well. We have our last member, Ruth Misiko. She's very talented in AI automation. She has mastered the skills, and she will help the team in handling all the matters pertaining to tech. So again, thank you for this opportunity, for allowing us to be here. Asante sana.
Good afternoon, everybody. My name is Topo Bilane. I'm the leader of the IoT Club. The club was inspired in 2018 as a way to bridge the gap between university and industry, and to be able to get problem sets from industry, so that when graduates actually go into industry, they have dealt with real issues which they can also use. Okay, from there, I'll speak of the overview, the future of IoT, the tools that are going to be used, and some of the learning outcomes. Okay, this was a brief introductory read that I used so that, but excuse my quality words. I'm just speaking to technological aspects. So from my background, I am a programmer. So I write code to solve real world problems. That's what inspired this quote by Steve Jobs. So Botswana is a key partner in the Square Kilometer Array project. We've got a semi-arid country where we've got a lot of sunlight. So we wanted to become part and parcel of these projects. The mandate of the IoT Club was to build grassroots innovation in data science, machine learning, and blockchain, or technologies of the fourth industrial revolution. we've got a problem whereby we've got a lot of artificial intelligence engines that are being used all over the world, but they do not have enough data in terms of information within the African context or the Botswana context. So we wanted to be able to help students using data sets, extraction, load, and transfer that data and help the students work with real data, i.e. African languages and natural processing. We should get to a point where in a few years, you should be able to command your artificial intelligence software using Setswana or my country language. So the tools which are needed for a person to achieve that is your Python, your laptop, and good internet. We've got a university called the University of Botswana, which has got all those things. It's got around 20,000 students. It's quite a huge community, so it will help us to facilitate that. So it's Toto Pilane, the team lead. Then we've got an organizer, Daniel Dube. He's got experience in Google Developers Group, Facebook Developers Group, and he has run a couple he's got experience running hackathons within that area. We've got Zane Swaba Tapelo. We've got Poloso Dumisang, she's a Master's in Cybersecurity Specialist as well from Botswana Accountancy College, and Gaya Moramaya. So since my skill level at organizing this was at an infancy stage, I asked some of my previous supervisors, Dr. Moteva, to actually help me in bringing up this team together so that I try and push my level best to create the best event in Botswana. Any questions, remarks will be very appreciated. Many thanks.
At least you know slides, right? Yep. It takes time to load.
So, hello everyone, my name is Chabili Langwane. I'm a PhD student at Stellenbosch University and also here at the observatory. And I'm also the president of the Zimbabwean Astronomical Society and team lead for this hackathon. Cool, so when we started the society back in 2024, we wanted to raise awareness of astronomy in Zimbabwe. We have a lot of people that were interested in it, but didn't know where to start. So we do this by having public stargazing events, of which we collaborate with the Astronomical Society of Harare. That's a group of amateur astronomers that meet quite regularly and have borrowed us their telescopes for our events. So we also do private outreach programs where we visit local high schools and we help them when they set up their clubs with material and stuff that they can do for their clubs. So for my team, I have Ashley, that's the first picture there. He just finished his master's at Stellenbosch University. We also have our vice president in the second image, he's doing his PhD at Lancaster University. And then we've also got Dr. Shazreen, a professor at the University of Virginia, and also Professor Nyambia. And then we've got Nkokeli, who's doing his master's at Livestock also. And the bottom images, we've got Praise and a few other team members that will be helping us online. So we're going to be hosting our hackathon at the Zimbabwe National Geospatial and Space Agency. So what they do is they use a lot of satellite imaging to map out agricultural land in Zimbabwe. And they also launched one of our satellites, SimSat-1. And one of our members for the society was one of the engineers that built this while he was in Japan. So it's really going to be a cool hackathon to have here. And we're hoping from this hackathon, we could have find more students that can be part of the society. So people that are interested in astronomy and data science. We also just want to show young people that they can participate in space science without having to go far. It's available in Zimbabwe and we can grow it from there. And we're also hoping that by hosting it at ZINGSA, we can create some sort of collaboration where we can have yearly hackathons or workshops with them. Cool. Thank you.
Okay, we have one more person who's going to be doing team introductions in person, and then we're going to move on to online participants. This one, right?
Yes. Yeah, good afternoon, everyone. Okay, so don't mind about my voice. I'm recovering from a terrible flu and cold. Okay, so my name is Zirami Kaluba. Yeah, coming from Mulungushi University, Zambia. It's actually located in the central province of Zambia. Yeah, so I'm the team lead for the hackathon which we're going to organize. Yeah, I'm a lecturer there under the School of Engineering and Technology, Computer Science Department to be specific. Yeah, I just understand actually about my background. I joined academia actually last year. I've been more in the industry as a software developer, and currently a PhD candidate also in informatics. So my team lead is comprised of those people. So there's Brian Habermans, also Dr. Habermans, who is currently the Dean of the School of Engineering. We have Florence Chimwisa, who is our technician and also a master student in computer science at the same Mulungushi University. And some students, those are actually two of them graduating this year. Then Amazon is actually, those are undergraduate students, by the way. But the other one is a fourth year student. So that's about my team. And just to mention, my colleague said that being the only, but so Mulungushi University in Zambia, we're actually the only university with yet to have actually an AI laboratory. So I'll leave it to you to judge which one is the best or the better. Okay, so we actually, it will be our first time to host this regional hackathon. So of course, we are looking forward to what will contribute and also what to learn. So the university gave us a facility, an infrastructure, which we have a multi-purpose facility. Yeah, and just to mention that our VC, of course, through our dean, he was actually very excited when we mentioned this to him and we showed him that. So he's actually in full support of it. Yeah, so that infrastructure actually has got a good internet connection, and it's actually used good for presentation and the like. then what we hope to achieve, believe you me, students, most of what they learn in class and the like, is more of theoretical. Yeah, so I believe hackathons actually, they expose them to practical problem solving skills. Yeah, and basically also to build innovation for development, of course, in readiness for industry, because at the end of the day, each and every skill, especially what we believe in computer science actually, or in development, each and every skill you develop at the end of the day is supposed to solve one or two problems. Just to mention, last but not least, so we're actually ready, I can say, to safely do a well-organized and impactful regional hackathon at Mulungu University. Thank you.
Before we move on to the online participants, I made a mistake. There's one more person actually who's going to be giving us a short introduction and what they hope to achieve during the regional hackathons.
Even. Introduction. Thank you.
Good afternoon, everyone. My name is Misomuhele Tusanga from South Lagi University in Kimberley in the Northern Cape province. So in our team, we have Mr. Freddy Nanyate, who is the team lead, but he couldn't make it and is in charge of our overall coordination. Dr. Silas, Gifne Magonde, Eva Mamabulo, as well as Mr. Buchiro Makado. The overall team that we have is the Geek Culture Student Society for SPU, and we work under the Faculty of the Natural and Applied Sciences Community Engagement. So we are a student-led technical and innovation society, and we will work to bridge the gap between classroom learning and practical industry experience. So we run code clinics for students, hackathons. Those are some of the annual hackathons that we have that are guaranteed to happen every year. We implement as well as mentor in hackathons. We do digital community outreach for the faculty as well as the university. We do VEPworks, we work on National Science Week. We work for the She Builds program, coding and robotics, as well as learner intervention support. And some of the partners that we work with are NRF SASTA, NRF Sarau, who else do we work with? DDAT, as well as the Department of Social Development. And so we are hosting the hackathon in Kimberley, which is the capital of the Northern Cape, at SPU Central Campus. So we are hosting it at the Central Campus because it has proven hackathon implementation capacity. We have established technical support structure, sustainable impacts beyond the event, because we don't only have solutions, and then we leave them there. The university has a center for rapid incubation and entrepreneurship, where we can develop some ideas even further. And what we hope to achieve is having research solutions, collaboration, prototype development, community building, as well as a stronger university hub. And thank you.
Thank you so much, everyone. We're going to be moving on to the online participants. We're going to start with Team Nigeria, followed by Team Tanzania, and then we're going to end with Team Iraq. Could you kindly just maybe like share your screen with us and do your presentations once you're ready? I'm not sure if Anthony is still not ready. So while we're waiting for him, we can just move on to Fiona from Tanzania. You can start with your presentation.
Okay. Could you share my presentation? Hello?
Hi.
Yes, hi. Could you share my presentation, please?
Okay, I'm gonna look for it.
Okay. Yeah, my name is Yona Sangula from Tanzania, particularly Institute of Accountants Arusha or Institute of Accountancy Arusha campus, Hackathon 2026. And I'm going to present my team from IAA. Welcome. Our team comprises of 5 members. Yes, my name, as I said, the first one, the team leader, Yona Sangula. We have Happiness Mkumbo, Haikaeli Makundi, Pamela Chogo, and Leonard Mutembe. These are Happiness, Haikael, Pamela, PhD candidate, and they are in final stage from the Nelson Mandela Institute of Science and Technology. And Mr. Leonard Mutembe also is working, he's also a PhD candidate at the University of Johannesburg, South Africa, also is in the final stage. Yes, next. Okay, so the hackathon will be held at IAA Arusha campus, and IAA, it is a government institution, and currently offering 81 programs, 15 master's program, 27 bachelor degree program, 20 diploma, and 19 technician certificate from various industries. Next. Also, IAA has 5 campuses. The headquarters of which is Arusha. It is located in northern part of Tanzania. We have Dar es Salaam, Dodoma, Babati, Songea, Ukombe, and the new one is Zanzibar. So the hackathon will be under the Faculty of Informatics, which manages a number of programs, and we expect it to take place from the 22nd September up to 2nd of October 2026. And we expect the hackathon to comprise graduate students, business, and experts from different parts. Yes, next. The goal of the hackathon is just to discover their talents and provide a room for networking, future collaboration, and also bring the creativity from the participants and create community innovation. So just a summary, because as we know, hackathon brings just problem solving, networking, and other issues. Yes, next. So we appreciate, and since it is our first time to conduct this hackathon, and we are sure that after this, the success of this will enable us to excel to the next of our campuses like Dar es Salaam. So we welcome you at IAA to share the experts. Thank you.
Thank you so much, Fiona. We're going to move on to the team in Nigeria. I'm not sure if you are going to share your screen or if I should do it on my side.
Okay, if you can share it by yourself.
You can start with the presentation.
Okay, thank you. First, I would like to thank Ikechukwu Anthony Obi. I'm the team lead from the Hack4dev team in Nigeria. First, I would like to thank the organizers of this wonderful events. I just have 2 slides, and please, can you get to the next slide? Hello? Please, can you get on to the next slide? Okay, thank you. So I'm Ikechukwu Anthony Obi. I'm an astronomer at the Center for Basic Space Science, which is one of the research centers under the Nigerian Space Agency. And we also host the West Africa OAD office. So this Hack4dev will be the first of its kind in Nigeria. The initiative was suggested by one student from Chinedu Naji from, I think, Witwatersrand University. He's currently doing a PhD. So he came up with the idea, let's try putting an application this year and see if we can host this event. And it was successful, but unfortunately, he has to pull out at some point because he just got admission to proceed for his PhD. So the team members are just the 3 of us, I, Ikechukwu Anthony, and James James is a PhD student at the University of Nigeria here in Nsukka. And Chioma Okani is also a PhD student, which she's currently on study leave, so she's not able to attend this event. The proposed event dates for the training is August 2026. That was the initial date, but from the look of things, it seems like we are going to shift it like a month later, September. So the major aim of this is to equip the participants, which will be primarily postgraduate students drawn from the southeastern region of Nigeria, to equip them with the hands-on skills in data acquisition, analysis, and visualization that is needed to solve real-world problems. So the idea is this: you have skills in Python or whatever programming language, but the question is, what can you do with the skill in terms of solving societal issues or problems that is connected to your research or whatever? And not just that, we are particularly concerned about the sustainability of such events. So we try the most we can to initiate long-term collaborations between the participants of this workshop and the trainers and industry experts. And we do hope that the event will be executed as planned. We'll keep you tuned on what is going on. Thank you.
Thank you so much, Anthony. We have one more person, which is the team in Iraq. Salah, I'm not sure if you want me to share your slides or if you will be able to do it on your side.
It would be nice to share from you.
Okay.
Hello, hello everyone. I'm Salahuddin Amr from Iraq, and that's my team, which is on the screen. Our team is from Abdullah Ayat, Ali Ismail, Noor Zubaydi, and Khayoun Al-Fayyad. This hackathon will be organized by Iraqi Space Exploration Allies. And next, if you please, next. Zwada, okay. It will be hosted by the American University in Iraq, Baghdad. Our idea to core mission, it's build the future by transforming science passion into practice, technology, environment, science, and data, invitation, and collaboration. Could you be the next? Okay. Okay, Hack4dev Iraq is the result of a strategic conversation between science communities, academies, and young innovators. And the Iraqi Astronomical Union is the youth science community dedicated to propelling astronomy, space science, STEM, education, invitation, and science across Iraq. Our Hackathon Dev Iraq organizer team brings together 3 teams, which is Andromeda Iraq and Hokonov's team and Kibler Invitation. Together, could you turn the next? Okay. Together, we work to empower young people through science, technology, researcher, and community in our vision for Hackathon for Dev Iraq will be hosted at the American University of Iraq, Baghdad. Through this regional hackathon, we aim. Could you be the next? Okay. This is our 3 team, as you see, Andromeda team, and Hawkonobis and Kibler Invitation. Next. Okay, this is the American space, IUIB in Iraq. As you see, it's a regional standing ground, academic rigor, and collaborate environment. Next. Okay. I told this before. Next, please. Okay, this is our vision and our idea from astronomy to data science. Next. This is our 5 staged players of Hackathon, Hack4dev Iraq. We want from the young people to come on the hackathon, and all the academic people in universities and from college and from educational school. Next. As I say, we want young Iraqi student, researcher, and tech student to invitation funnel and by the Hack4dev at IUIB, real world challenge and collaboration. So we want to be the next generation teach leaders. Next. And also we are excited to represent Iraq in Hack4dev by priding the vastness of space science with the rationale of data science. We are building a strong, lasting impact for our nation and the next generation to lead. Next.
Yeah, I think that's it.
Okay. I was asked a question. Our team, our friends team in another countries, they want to become in our hackathon as get help or just for the hackathon. So I asked it before, and they told me to ask you if you accept to to do that or not.
I'm not sure if I understood the question. What exactly are you asking?
They wanted to include people from different countries, if I understand.
You want to include people from different countries during your regional hackathon. So
Yes.
you're asking if it's possible for you to do that or not?
Okay. Should we discuss after the hackathon?
Yeah, we can do that. Yeah.
Okay, that's great. Thank you so much.
Thank you.
Okay, I don't know how, but we managing to keep ahead of the schedule, so we're 30 minutes early. So you guys might have time to go out and explore Cape Town. We'll see. We'll see how the weather holds up. So now we'll take a tea break, and then when we come back, so it'll be Prostron introducing the challenge and what's left. I think that was it. Oh, Nandi is here as well. Do you want to say something, Nandi, or just meet people during coffee break? Maybe after coffee break, you can come and introduce yourself. Okay, 30 minutes. So for those online, we will be back in 30 minutes.
Okay, welcome back everyone. So this is the last session for the day. Before I give to Prof. Thron, I'd like to invite Nandi from REES to briefly introduce herself and what REES does. So REES is one of the organizations that funding Hack4dev. So some of you are receiving money from it. You can come here.
Hello everyone, nice to meet you. I am Nandi Mutete, an engagement manager at REES, which is the Research Institute for Innovation and Sustainability. I am formerly a mechanical engineer, but I currently head the data science department at REES as well. So building applications using space-based data for climate change, illegal mining, and other applications as well. But the reason I'm here today is because of a program that I am the manager for, which is the Africa Earth Observation Challenge. It has been running for the past 10 years. Started in 2016 with the South African National Space Agency, also doing exactly what you guys are doing now on the astronomy side, using the data to solve our community problems. And the reason why we're supporting this is because, one, we want to bring together the space community. There's fragmentation between the people that are working in space, the satellites and the cool things, the people that are working in astronomy. So bringing that together, but also making sure that people are using the cool technologies that we're all coming up with, the data that is available to make sure that we're solving our societal issues and so on. So I'm keen to see what you guys come up with and to see if some of you can come over to my program as well at the end of this. Good. Thank you.
Thank you very much. So now we'll go to Prof. Thron for the hackathon challenge.
Okay, here we go. I'm probably not going to use that because I use my hands. But I think my voice is loud enough because I've been teaching for some time. I mean, yeah, okay.
You got the Zoom ready as well?
Oh, sorry, I don't have it, sorry. Let me go there. It was in my email. Always have to deal with some, there it is. I'm going to join the browser. Okay. Okay. You'll have to mute that. Oh, I moved my microphone, sorry. I am muted.
I think mute the speaker as well.
I'm muted.
The speaker?
Oh, okay. Nice. Okay, good. All right. Okay, well, that's you. Okay, so the hardest part of speaking is getting started. So let me just introduce myself briefly. This slide is quite old, but it gives you some idea of my background. I got my bachelor's and PhD in US. After that, I went to China for 5 years and ended up teaching English. I also got married there. You can see my family. It's an old picture. I think my son is older than maybe most of you. He's 38. So, and 3 other children. After I came back from China, I went into industry. So I have a background in systems engineering. At Motorola, which used to make cell phones, and later on, and before that at NEC. After that, I left in 2010 and joined academia. So this is my current university, Texas A&M University, Central Texas. I've been there since 2010. And since about 2014, I have been coming to Africa on a regular basis. I've probably been to more countries than most of you. The first country I went to was Chad. Anybody here from Chad? Anybody here been to Chad? Okay. Anybody know where Chad is? Okay. So, and after that, Cameroon, Nigeria, Benin, Sudan, South Africa, Rwanda. I usually come at least once a year. I stay several months. I teach workshops, I teach classes. I think I started teaching machine learning about 3-4 years ago when I realized that this was really the future, especially, my area is mathematics. So this is really the future for mathematicians, and I think also the future for Africa. Just from my perspective in both places, I can see the gap widening. It really is becoming like two different worlds, and it's not healthy. It's not healthy for us. It's not healthy for you. It's like right now you have the World Cup, right? Everybody plays on the same playing field, but there's not the same playing field anymore. We're playing somewhere, you're playing somewhere else, and it's not good. It's just not good for the world. Well, I forgot Morocco. Okay. So, okay. So I really believe in this. I really believe in what you're doing. I'm very grateful to be a part of this. How I got involved in this is another long story, so I'll skip that. I want to spend most of the time introducing the challenge, which I did not create this challenge. It's thanks to Eslam Hussein, who is now in Leeds, getting his PhD. You probably hear his name several times, but he's pursuing his PhD. So I was tapped to take this over, and I know Eslam for a long time. And he's actually the one who got me into this. So who has read the notebooks? Who has looked at the notebooks? Who has the notebooks? Okay. All right, so please take some time to look at the notebooks tonight. I think it will be very helpful. Just a few minutes to get some background. I may pass through them quickly, but I'm presenting a slide presentation. So I did not realize I was presenting today. So I'm sorry I was not very sociable during tea break because I constructed my entire presentation since noon today. So this is really a story about how AI changes everything. I think it would have taken me over a week to create this presentation without AI. However, it's also very frustrating because I think some other people have. Who's used Gamma? Anybody use Gamma to create slides? Yeah, I think I recognize some Gamma because their fonts are so small. I'm 68, so I can't see like that. So I try to make the fonts big and they make them smaller. So there's always these small things that you need to fix. So I had to go through and fix the whole thing. But anyway, it's a good experience. So we're all learning. And I do think one of the themes that this conference should, that this workshop should emphasize is the efficient use of AI in development, how to use it correctly, and not substitute for thinking, but as a dialogue partner. AI can generate some wonderful ideas, and it can also take you way down the wrong road. And you need to know, you really need to have some intelligence to know the difference when AI is taking you the right way or it's taking you the wrong way. In fact, a lot of this project was also heavily dependent upon AI. So I even need to figure out where I am. Okay, all right. So the topic of the hackathon is building age from space to transferable classifier. All right, so it's not building age, it's age of buildings. We're determining the age of buildings using data from satellites. So let me say that again. We're using satellite data to determine the age of buildings. You know, there are satellites that orbit the Earth continuously. They're always taking pictures. They're taking pictures of us right now. If you use Google Maps, you can see they have a complete map of the Earth. And they also have, and not only these satellites that take visible light, but they take the pictures in many different spectra. So they take infrared and so on. And this data can be used for many purposes. I think it's used in agriculture, it's used in flood planning, and it's also used in urban planning. So one of the things you can use this data for is to get information about buildings. And the idea here, which came from someone who studies urban planning, is to use this data from satellites to automatically determine the age of buildings in your satellite photograph. Right? Now, what's the motivation? The motivation is that how old the building is determines how it behaves under stress. If you have, for instance, if you have an earthquake or you have fire, then the age of the building old buildings may respond differently to new buildings. New buildings may have fire codes or things like this. So if you can classify the age of buildings, this can help you in urban planning and make effective policies. So this is really a practical problem, and one that is quite publishable. That's the background. By the way, I do want you to feel free to ask questions at any point. It helps me because I don't know if anybody is following me or not. So let me just pause and ask if you have any questions here. Or just feel free to speak up. We're not a large audience, but I will try to pace myself. I am a mathematician, so there are some equations. Don't be frightened. Okay, I can slow down, and I try to express the ideas not just in equations, but in words. Okay? It is quite important that you understand this challenge, because I think, so I'm going to try to be very careful to explain it, because it's very easy to do the wrong thing. You need to understand the goal of this project. And I really don't want people to spend a lot of time doing the wrong thing. Right. My battery is running low. Can I plug in somewhere? Yeah, I need my charger and my battery. Okay, just plug. Oh, here. Oh, yeah. I think did it go out? I went to sleep. I have discovered that South Africa is the center of the universe. The reason is because the plugs that you use are nowhere else on Earth. Nowhere. Okay, so I'll have to connect again. I probably have to, I'm sure I will have to connect the Zoom again because it would be lost. Yeah, so let me go back and do that. Yeah, I'm still connected there. Well, look, I'm still connected.
Yeah, I think you just need to share your screen.
Oh, okay, yes, okay. Okay. Here we are. All right, so let's move on. All right, so the data that we're going to use is from Landsat. Landsat consists of a system of satellites that have been orbiting the Earth since 1972. And they are taking pictures all over the Earth. We are going to be looking at pictures of urban areas. And buildings, as I mentioned, have certain spectral properties, both in the visible and infrared spectrum. And you don't need to know a lot about spectrum or electromagnetism and so on. In this project, this is just data, right? You don't really need to understand too much the nature of the data. You do need to know that this is data from several years. I think there's some data, there's image data from every year. There's one image from every year. Okay, so that's important. Right. So over the world, there are many, many cities, but there are not many cities that have building age labeled. Here we have data from the satellite, but how do we know the age of the building? we also need someone on the ground to label the ages of buildings. There are a few cities that have this. One is Amsterdam, one is Madrid. You will be using data from Amsterdam and Madrid. Okay? So the goal is to create a model using Amsterdam and Madrid that can be used also on other cities that are not in your data set. All right, so it's good to keep that in mind. I'm not just trying to find an accurate classification for Amsterdam and Madrid. I'm trying to find a method to classify for any city. I'm using Amsterdam and Madrid to develop a generalizable model that can be used for any city. So please keep that goal in mind. We don't want to get too focused on becoming very accurate for one city. The key is to make it something that can be transferred. All right, so I don't need to go into too much detail about the data. Just you can see there are quite a few image pixels. So for instance, Madrid is 76,000 pixels, and then you have 40 years of data. So that's 76,000 times 40. Well, it's 76,000, that's actually 76,000 data vectors. Right, so each pixel is going to be one data vector. You're going to follow that pixel over a 40-year period. So that 40-year period of data for one pixel will be one data vector. And we want to use that data vector to predict the age of the buildings in that pixel. The pixels represent 30 meters by 30 meters. So that may be a few buildings. But typically buildings close by have about the same age. I mean, you think about the buildings in this complex, most of them have the same age. Okay, we decided on 4 age classes. We have data from 1984 to 2024. So we have 40 years of data. So we decided to split that 40 years of data in half and try to classify the buildings before, what's the middle of that? 2020, let's see, but 2004, okay. So we're trying to distinguish the buildings before 2004 from the buildings after 2004, all right? You might think that when a building is built, there's some change in how it reflects light. So we hope to detect that change. But further, we wanted to see if we could use the model to detect changes before the period in which we're measuring data. Okay, so we chose one of significant events in each city and used that as a dividing line. I think in Amsterdam it was at 1945, because after World War II there was a building boom. So buildings before 1945 have very different characteristics from buildings after 1945. In Madrid it was a different dividing point, but there was a certain period under the Franco administration where they started building modern buildings. So I think it was 1960, something like that. So we have 4 classes, okay? So the job is easy. To each one of these pixels, you want to assign a number, 1, 2, 3, or 4. And that will indicate the age of the pixels, the age of the buildings in that pixel, okay? Is that making sense, some sense? Now, please, I think if you read the notebook tonight, it will become very more clear. But I just want to give you a big picture. Yeah, question.
What about the background pixels?
We kill them out.
Oh, okay.
So, all right, that's a good question. There's water, there's parks, there's things like that. But we did take them out. We did a lot of cleaning. Actually, Aslan did a lot of cleaning. Thanks to him. So I would like to say that in some way you are cheating because a lot of the hard work was done for you. The idea was to focus on the data science problem, but really that's only a part of the entire process. And I was talking to somebody that maybe in future hackathons, we might change this a little bit so that people have experience in the earlier phases. But for this hackathon, it's really focused on the data science aspect. And that's good also because of course you're not a specialist in this area. Once you get it to data, it just becomes a data problem, right? You really don't need to know too much about the background. So that's one of the nice things about being a computer scientist, because You can put your fingers, in US, we say, put your fingers in many pots. So, okay. So, all right. So what we're trying to create is not a classifier, but a method for creating classifiers. All right, let me say that again. What we're trying to create is not a classifier, but a method for creating classifiers. Why do I say that? Because we want to classify buildings in different cities. Different cities have different characteristics. You can't use a classifier for Amsterdam and just expect it to work in Madrid. Right? You certainly can't expect a classifier for Cape Town to work in New York City. It's just very, very different type of buildings, right? But what we want to do is use data from some cities to be able to easily create classifiers for other cities. Right? So what we're trying to do is actually create what we can call this model create. I call this model create a function. In fact, machine learning is all about functions. What is a function? A function is anything that takes an input. Function is anything that takes an input and produces an output. So a classifier is a function that takes in data, image data, sound data, and so on, and produces a class, right? Here, what we're doing, this function that we're creating is how can I say this? Well, it's a function that produces a classifier. We want to have something that will take a small amount of data from a city and produce a classifier for that city, right? Right. So this is what is called meta learning. Okay. You're not just learning, you're learning how to learn. Okay. So you're going up one level. Okay. So I need to hide this. All right. Okay. Okay. One of the nice things about Gamma, if you haven't used Gamma, I suggest that you take a look. It actually produces very appropriate images. The text is kind of wonky, but it produces wonderful images that are, so here it's kind of making a factory for classifiers. So, all right, so here's the problems and specification. And I think this is more clear in the notebooks because we go through step by step. Right, so first you're going to use Madrid data to design this model creation methodology. Okay, all right, then we're going to, what we want to do is we want to evaluate this model creation methodology. We want to see how effective it is. That's where Amsterdam comes in. So I do want to, and I will be re-emphasizing that, to create this model creation methodology, use only Madrid data. Do not use the Amsterdam data to design your model creation methodology. That's cheating. That's cheating. Because we want a method that can be applied to new cities. So we can't apply the method to the new city that we're going to test it on. Madrid is for developing the what I call model create. Amsterdam is for testing it. Okay, so keep those two functions very separate. There's the creation, and there's the testing. Right. So what you're going to, so what model create is well, your model create is actually going to be a Python program or a cell in the Jupyter Notebook. And this cell will have inputs. The inputs to this cell will be a small amount of data from a new city. Small amount of data from a new city. And the output will be a classification of the pixels in that data. Right. This is going to take some time to process, I think. So if you don't get it 100% now, that's fine. All right, but keep this in mind. All right, and so you're going to apply this model create to small samples from Amsterdam, and then see what the accuracy is. And there is an example in the notebook of a particular classifier that I developed as a benchmark. That you can see one example of how you might do this, and try to do better. Okay, so that's. Okay, so I said there's going to be some math, but Word is just a language, and you know, people in Africa are very good at languages. You speak 4 or 5 languages, right? So just speak, it's just another one, okay? Okay, it's just another one. Okay, all right, so, all right, so in data science, typically you have the data vectors and the labels, right? If you're classifying images, you would have an image of a cat, you'd have the picture, and then the label is cat. Image of dog, label is dog, right? So typically they'll use the letters X and Y. So X is the data that we're going to use to classify, and Y is the classification. So Y is a number 1, 2, 3, or 4, because every vector has a classification that's either 1, 2, 3, or 4. Right. Then X is going to be this string of data corresponding to 1 pixel. Okay. So we define these pairs. I call these pairs. I just call that D. Okay. So X is the data, is the pixel data. Y is the label, and D is the combination. Okay. These are the entire sets. So as I said, for Madrid, I think there's 76,000 point values vectors in capital X. Where's my, why doesn't it show? Okay, there's 76,000 individual vectors in this set. This is one particular set, but one particular vector, small x. So small x is one vector in big X. Okay, small x is one data vector. Now, since we're going to be selecting data vectors from different classes, I'm going to use small xij to be the jth vector from class I. I wish I had a blackboard to write on,
This one back there, but
well, it's all right. You'll just have to imagine, I suppose. All right.
We'll investigate.
Okay, yes, okay, all right. So we have this big set of vectors that characterize the entire city. And we're going to be using a smaller set in each new city in order to develop the classifier for that city. Okay, so DC is the data vectors and labels, the complete data set of data vectors and labels for a city, for a particular city. Right? DCN is a small subset of that big set of data that consists of n vectors from each class. Okay, so if I take 25 vectors from each class, then DN would consist of 25 times 4 or 100 different vectors, 25 from each class. All right, so this is the process. Okay. So I'm repeating what I said before, but this is in mathematical notation. Okay. Right. So number one, you're using all of the Madrid data. You're using all the Madrid data to create the model.
Here.
Now, if you all right. So let's see if we can. So we have X. We have 4. We can follow that. So let me just say I'll just say index. And we can have, because we're using Python, the first index. Anybody know what the first index is in Python? 0. Okay. Yes. Okay. So I'm going to do like this: 1, 2, 3. All right. So this is the first data vector and the first label. So this will be several values. I don't remember how long this is. I think it's 70 different values. And because each year has several values, and we have 40 years. So there's a lot of values here. I just indicate those by I suppose. Okay. And then this is going to be one label. Okay. I'll just call that Y0. So Y0 is either 1, 2, 3, or 4. Actually, I should have done 0, 1, 2, 3, but whatever. So this also is going to be a vector of values. So just indicate that. This is also going to be a vector of values. Okay. Same length. They're all the same length. And so these are all. I'll call this the pixel index. So each pixel is going to have this vector. Each pixel is going to have a label like that. So typically, you will arrange this in a big array like this. Okay. If you know some Python, you should know something about arrays. Okay. So what do I want to say now? Okay, so this is the entire set So I put a subscript here to indicate what city it is. So maybe this would be Madrid. Okay, then I would have the labels for Madrid also. So this would be all of the Madrid data that I'm going to be using. We'll have a similar set for Amsterdam. Now, what about these smaller sets? So for instance, let's say this one is a 1. I have a 1 down here, I have a 2 here, a 2 here, 3, 3, something like that, 4, 4. Am I not okay? So the smaller set, I'm going to select some of these, but like suppose if I wanted to find X2 of Madrid. Okay. X2 of Madrid would mean that I would take 2 vectors of each class. Okay. So I would take maybe this one, that's class 1. This one also is in class 1. Okay, so that would be 2 vectors. I take 2 vectors from class 3, this one and this one. 2 vectors from class 2, this one. I will do another 2. Okay, whatever. 2. And then 2 vectors from class 4. Okay. So all of you mathematicians out there, how many vectors is that? We take 2 vectors from each class. Yeah. Yeah, okay. It's not a trick question. I can see you all enjoyed your math classes. So, yeah, that's 8 vectors. So the idea is to classify a new city. You would take a small subset from that city's data and only use those vectors to create the new classifier. So I hope that gives the general picture of how we're organizing the data. Right. So with Madrid data is going to be used for model create. The Amsterdam is going to be used for the evaluation. Okay. So you'll be taking small samples. Now we want to see how small we can get. How small can these samples be? So you're going to try some different values, 5, 25, 50, 100, and 200. See if you can adapt this model with only 5 vectors from each class in the new city. That would be wonderful. Okay, we'll see how we can do with that. All right. So you use a small sample from Amsterdam, and then you use that small sample to create a predictor for Amsterdam. Okay. Right, so as I said, model create is a predictor creation mechanism. I'm using model create to create a predictor for Amsterdam. Now, what does that predictor do? Well, that predictor works on Amsterdam data. Okay. So I'll use that predictor on Amsterdam data, and then we will evaluate. Okay. So that's an evaluation. If you know about, there are different ways to evaluate a model. There's accuracy, there's F1 score, there's recall, there's some other things like this. In this case, I think actually because the classes are balanced, here I said F1 score, but it's probably just the accuracy. We'll get the accuracy and the standard deviation. Okay, I've been talking a long time. Any questions? Yes.
Okay, so I'm trying to get how this works. Like I look for classifying evidence.
Yes.
So hypothetically, like building the messages would take 10 more years.
Okay.
Yeah. So like in, let me say now, like I don't know if I have in, let's say in Africa, in like
yeah.
So those the process. Maybe we run out in 1 to 2 the process stops.
Okay.
Yes.
Yeah.
And leave the on is
okay.
Yes, like maybe after you say 5 to 10 years.
Okay.
So when you like calculate the productivity change, like how are you going to like go about that?
Okay. The answer is I don't know, and I don't need to know. I don't need to know because that's what the urban planners do. They have, that's what the urban planners do. They have some definition of the building. Okay. I don't need to worry about how they define it. All I need to do is be able to predict what they define. It's a good question, but this is data science. I don't need to know that. Now, I'm not just being funny. That's actually true. You don't, if you're doing data science, you don't really need to know how they created the data. You just need to be able to create.
My question, I'm trying to understand the infrastructure.
Yes.
So X is not our image, it's not the image of maybe a Soviet country.
Well, it's each Roman X is a pixel.
It's a pixel from let's say pixel 0 from different images of different games.
Well, pixel, I wonder if I can pull up the data. Well, here, let me just show you on the board. That's good. Now that we have this high tech, we have this high tech here. So let's suppose we have Amsterdam. Okay, so we have 40 years of data, right? So maybe this is 1984, it's 1985, 1986, and so on. Okay. And I don't remember the shape of the data. It's something like maybe the same shape of the data. The same from year to year, right?
Yeah.
And we're dividing this up into pixels. Same pixel for each year. Same pixel for each year. Okay. Now, when I say a pixel, I mean the same location for every year. That is one pixel. Okay. Is that same location across the entire span of years? Okay. And that pixel, as I said, may contain multiple buildings, but we assume that they're all the same age. We can assign one age to that pixel.
Yeah, it's a image then divided into different pixels.
Yes, that's right. That's right. Yeah. Right, very good. Okay. Other questions? Yeah.
All the different bands. Like
No, they all have the same data. They all have the same spectral data.
oh,
But if you're asking me, do they have different characteristics?
like
I hope they do.
because it's time series data.
It's
right?
time series data, yes.
And is it like is each pixel does it contain multiple bands from the satellite or is it just
Okay, I think if I understand your question, the bands that are created each year are the same.
okay so
You have the same,
Oh,
like I think you have RGB and then there's IF. I don't remember what they are. IF, something like this. You have these numbers for every year.
oh okay.
Okay. So it's always the same. Yeah.
Then it means they're standardized, like all
They are standardized. Yes, that's a good point. I actually had to be careful about that. That they're standardized from year to year. So it should be that you can compare across year the same data. That's very important, right? Because if the building is built during the period, you expect a change, right? And you want to be able to detect the change. Okay. So that's very important. So we did standardize the data. Other question? Yes.
Okay, so I have the question. So like let's say one of the buildings can change, but the change is only on the OC. So like how does that also like affect the age of the building?
Okay, all right, so again, that's true. So the change, there may be changes during the period being built. But I don't know, I just want to be able to tell that something happened, right? Okay, when some idea that something happened and that something was, if you pour down one building, you created another one. Okay. Good questions, thank you. Other questions? Okay. Okay, yes. Okay, yes, of course.
So you mentioned that you want to do something changes for the building.
Yes.
How will you be able to store the image if you have detectable?
Okay. Well, and that's also one of the things I don't need to know, but I can guess that if I see some change, when they change, so maybe I see some, like, for instance, let's just take red, okay? We can just plot red as a function of time. Okay, so just suppose we have something like this. I'm taking one pixel, I even coded red, so Okay, so I'm taking 2 pixel and I'm taking the value of red over a certain period of time. So this would be 1984, 1985, and so on. Now suppose I see something like this. All right, so 1984 is here, 1985 is here, 1986 is here. Then I see something like this. And then I see something like this. So this is the period, this is what happened. What do you think that means? So something happened in here, right?
Yeah.
Okay. So I would hope that I would suppose that the age of the building, if they make the age of the building when the building is completed, I would suppose the age of the building is this year. So I want the algorithm to be able to pick up things like this. So it will pick up maybe changes in level, something like this. And one of the things about machine learning is you don't want to get too involved in the details. You want to let the machine do all of this. So I don't know what the machine is specifically looking at. I just need to know, is it doing well? If you know something about image processing, I mean, it's amazing how well image processors can detect cat or dog. Anybody use Google Lens? Yeah, okay, it's amazing. So like you take a, like I was in Benin, and there was some vegetable there. I didn't know what it is. So I took a picture of the vegetable, and it said, you know, this is very bitter. Don't eat this. Okay. So how do I? But I can't ask it. How do you know this is that vegetable? It can't tell me, right? It can't tell me. It can't say, well, the shape was something like this. It just said, I know. Trust me. Right? So that's what machine learning does. It finds the answer, and you just have to trust it. Okay. Right. So, all right. So that's what we're doing. So we want to just to recap. This model create is going to enable us to generate classifiers for new cities with a very small amount of data. All right. Now, I emphasize this again. Data leakage is one of the great dangers in data science. You can say an analogy. You teach your students a course, and then you want to see how much they know. Okay, so you want to give them an exam, right? Okay. So suppose you give them the exam questions before the exam. Okay. Suppose I tell them, okay, I'm going to ask you these questions on the exam. So then everybody takes the exam, everybody gets 100. Do they understand the material? They don't understand anything. Okay, that's what data leakage is. Data leakage is that you're actually using the data that you want to evaluate on in your training. Okay, it's cheating. And it does not, it will give you a classifier that cannot be generalized. They do well on that exam, but you give them another exam and they can't do anything. Okay, so I just say this as I said before, use Amsterdam data. Okay, let's see. All right, this is back. Oh, yes, it says do not, do not, do not. The not is very important. Do not use Amsterdam data to design model create. Madrid data only. And then do use Amsterdam to evaluate. Right. Now, how are you going to evaluate? Maybe I should draw this process on the board. So we've got this big, so we moved this data for Madrid. I have this big X, and I have this Y. Now, if you know anything about machine learning, you're going to have to divide this into training and testing. To develop your model, you're going to have to divide this into training and testing. So possibly this part will be training, and then this part will be training, and this part will be testing. I can say training and test or training and validate, but it's about, in this case, it's about the same. Now, from this data, I'm going to use my machine learning techniques to develop this model keeping. Okay. Now, what does model create do? Let me take my Amsterdam data. Okay, I wonder if I can actually do this. Okay, so this is Amsterdam. And this is the latest. So this would be fast. Okay, now remember that model create takes a small amount of data to generate a model. So, for instance, I can take a small amount of Amsterdam data, and I'll choose this data randomly. I don't want to choose all the pixels in the same place, but I'll choose this data randomly here, and I need the corresponding labels. I'll choose this data randomly, and that will become my x sub n and y sub n. Actually, let me make it smaller because I have to do something more. Let me bring it up here. So I'll have my x sub n and my y sub n. Well, now, what does the n mean? N is the number of vectors in each class that I chose. So perhaps I could be x, if I have x of 5, y of 5, that means I would have 20 vectors here. Okay. It's a small data set. From this small data set, I'm going to create a predictor on Amsterdam. I say predictor and classifier is the same thing. Sorry if I use both of those words, but predictor and classifier is the same thing. I'm predicting the class. So I did this predictor for Amsterdam. Then do what?
Just to try to get the steps.
Okay, get it.
We take the manipulator.
Yeah.
Then you have a train data from the matrix.
Yeah.
Then from there, you tap into the matrix, then you try to get another data flow.
Yeah. So what? Well,
step 1 to step 3.
The key is that this Amsterdam data is giving me this, and I need to give you an example of how this works.
Oh, you don't get that from matrix.
I do get this from matrix. Yes.
After testing.
Yes, after testing. This is the point. This is actually the important thing that I'm getting from you. Then I use this here to
I'm sorry.
I should say that here's where I apply model create. Okay. I should have put that there. I take this small data, I apply model create here to create my predictor. Okay. Right. Now this predictor, I'm running out of space, then I'll evaluate the accuracy of this predictor. Okay. So this predictor will have an accuracy. Okay. Maybe it predicts 90% of the pixels correctly, something like this. I don't think it's that high. I think it's more like 70. But anyway, so this will have an accuracy. Right. Now the problem is that this is not enough to show me how well this model creation is working. Why? Because this is only one case. I could have been very lucky. I could have been very lucky and gotten a good predictor. Or I could have been very unlucky. I will have to do this several times, not just once. That's another point that I'll make later in the talk, is that whenever you get an accuracy, you always need to get that error. Okay, you know, if I say my model is 95% accurate, that's BS. You always have an error bar. You can't say it's whenever you do a scientific measurement, there's always an error bar. How am I going to get the error bar? I'm going to have to do this many times. I have to get many accuracies, and then I'll have to take then you'll get a distribution of accuracies, and you take the mean and standard deviation. Okay. So if I just try to complete this picture, I'm going to be doing this again. And you'll be doing this again with another set of vectors. I'm going to be doing the same process again, creating another set here, okay, doing model create on this, then getting another predictor, and then getting the accuracy. So I may do this 100 times. Now, again, I think this is not easy to follow, but I do have an example in the notebook. Okay, so you can actually probably just use the code there that I used on my model create and use it on your model create. Okay, but you'll get there just step by step. Okay, if you haven't seen the notebook, I think you'll be surprised how well you can get there. So, all right, so let's go on to the next. Okay, so this is what I was saying that you have to generate several of these small models for each of them, and you have to take the mean and standard deviation for all of those. Now in the notebooks, there's one example of a model create, and this approach actually was suggested by AI. I don't remember which one. Probably I was using ChatGPT at that time. But, so I told it the problem, and I would suggest you do the same thing. I really would suggest you do the same thing. Tell AI the problem and have it suggest to you some approaches. Now, you don't have to follow what it does. It will give you several approaches. You should look and say, well, this one I know something about. I have some experience here. This one makes sense to me. I'm going to choose this one. And you work that way. I think the time is too short for you to try to understand all yourself. So ask AI for an approach. Okay. So what this approach does is it uses Madrid data to learn a distance function. Okay, let me see if I can explain this a little bit. All right, now, each one of these rows here is a data row. Right? Each one of these rows represents a pixel. So let me call this pixel P1, pixel P2. Now I want to represent P1 and P2 in, let's just suppose I have a two-dimensional space. And I want to represent P1 and P2 in using 2 dimensions. So maybe P1 goes here, and P2 goes here. Now, what I would like to do is represent P1 and P2 using points in this space so that points that are in the same class will be close in this space. If you know anything about machine learning with large language models, when they talk about vector embeddings, this is exactly what they do with vector embeddings. Right? They take your words and they represent it using a vector, and words that have similar meaning will be close vectors. Okay. So that's exactly what we're trying to do here. We're trying to correspond every pixel to a representation so that pixels in the same class will be close in this representation. So that means we do pixel goes to representation. And I can say it's a vector representation. And there's 2 vectors that are close, which should be in the same class. And then and what does close mean? Close means the distance is small. So what you'd hope to have when you do this mapping, you would hope to have 1 cluster, 2 clusters, 3 clusters, 4 clusters. And each cluster would correspond to a different class. So that's the idea about that's the idea about distance, about metric learning. Okay? You're trying to assign clusters to each class that you're trying to classify. Questions? All right. Now, this is just one approach. You don't need to use this approach. I'm just trying to explain how this one works. Okay, all right. So you learn a distance. Okay, and this is actually not quite right. What you do here then is, so this is Madrid. Okay. Now suppose you apply the same representation to Amsterdam. Suppose I use this same mapping from pixel to vector, and I use that for Amsterdam also. Okay. So for Amsterdam, I would still have this, X and Y. And then I would have a distance function. So I have a representation in this space. Now, if I only use a small amount of data from Amsterdam, I would still hope that those small amount of data would have clusters. Okay. The clusters may not be in the same place. So the behavior in Amsterdam and Madrid may not be exactly the same, but you would hope that this correspondence would maintain closeness between different classes. Now, then the small amount of data will determine 4 new clusters, and these clusters are what I will use to classify my Amsterdam data. So I'm not using the same classifier. I'm using this classifier to create a new classifier that's based on the same representation.
So,
yes.
So the data model doesn't have like image doesn't have to be from the same image graph. Doesn't care whether the building in Amsterdam and made of this image graph, one that I might do that based on this image graph. Well, it just pick the similarities in cluster.
It does. I'll give an example later on, but it does care about the different materials. The material will determine where the cluster is, right? So maybe I can give the.
Oh, I can say the materials doesn't have to be the same.
Okay. Let me give an example. Okay, maybe this will be helpful. I thought of this today. Suppose I want a machinery model that can classify the model of cars. Like you have different models here. Everybody likes RAV4, right? You have RAV4, you have Camry, you have Corolla. I'm not sure what other models you have. Okay? So suppose I want to develop a machine learning model that can classify cars from the image. Okay. All right. Now, suppose that I only have Honda cars. I only have Honda cars, but I want a classifier that can work on any model of car. Okay. So that's very much the same type of problem we have here. Okay. I want to be able to classify any type of car, but I only have Hondas. So what am I going to do? Well, in my picture, my machine learning can look at various things. It can look at the number of doors, for instance. Maybe it can look at some aspects of the shape. It can get some general features of Honda. And then it can use those characteristics to classify the Honda car. Right, Honda Elements looks like this. It has this kind of roof. It looks something like this. Right. So it knows what to look at. So it will look maybe at the size of the tires. It will look at the number of doors. It will look at the shape of the hood, something like this, and it knows that those are important things to look at. Now in Honda, those characteristics will determine the Honda model. Okay.
So, for example, let's say I take the Madrid model.
Yeah.
Then I apply it to the buildings challenge of
absolutely. Yeah.
So you should be able to pick those patterns.
I don't use the same model. I actually did it together. That we use the same model to put a model. What you have to do is you have to take that model. So what I was trying to say was that, for instance, if you take your Honda model and you see a picture of a road, right? Now in Toyota, right? Camry. So in Honda, I know that 4 doors, I don't know what 4-door Honda, it's not some car, right? So if I use that same criteria in Toyota, I assign that 4 doors to a different one, to a different class. I'm not assigning it to the same class, I'm assigning it to a different class. But I'm using the same characteristics. So it's not the same classifier. I'm taking my own classifier, I'm taking features from it, I'm using those features to create a new class. All right? So I'm not using the same classifier. Okay, yeah, it's going to take a little while to understand this. But this is the basic point. I think once you get past it, you'll see. You're taking the Madrid model, the purpose of the Madrid model is to identify characteristics. Okay. Then you're going to apply those same characteristics to Amsterdam, but those characteristics may determine different classes. Right? It could be that in Madrid, the old buildings are more reflective. It could be in Amsterdam, the new buildings are more reflective. Right? So you're still looking at the reflectiveness, but you're assigning a different class. Okay? You're using features from Madrid and applying them to Amsterdam, but you're not applying the same label. Okay? Does that kind of make sense? Yeah. Yeah, take that, yeah, you will get there, yeah.
I was just to make clarity. Would I be maybe wrong thinking to say maybe the manipulated data is more complex? That to a point where maybe you think if the model can perform better from the natural it will obviously be able to validate easily instead of what I said.
Well, I don't know if that's necessarily true. I think that's maybe a good way to think about it, that the same general features can be used to distinguish. But how those features are used may be different. So the point is to use Madrid to identify general features. Then once you identify those general features, then you use a small amount of data. Right? Well, this feature goes to this class in Amsterdam. The same feature might go to a different class in Madrid. And this feature now goes to this class. This is very good. That's your last.
The features are all taken by second. The quality is the same.
The quality is the same, but what's different is the characteristics of the building. They're not. Yeah.
But is this like a feature engineering problem?
Well, it is. Yes.
Okay, rather than like a model training.
Well, I mean, what you want to do is have the machine learning discover the feature.
So learn.
Well, I mean, this is one way to do it. But this distance function is telling you, well, if I do this mapping, this mapping is able to distinguish between classes. So we want to use the same mapping to distinguish classes in the number. But feature engineering is certainly one approach you can do. And you might try that. I think that would be very important. Like you can say older buildings, perhaps one feature, and I think we found this in the data. One class of buildings, the reflectiveness is very variable. Right? So you can use variability. Maybe Amsterdam, the old buildings are more variable. In Madrid, the new buildings are more variable. But you can still use the variability to determine the class. Okay, so that's good. Yeah, okay. Very good questions. Thank you. I think I'm almost done. I shouldn't go too much into metric learning because this is just one example. Okay, so I don't want to go too much into this. This is more technical detail. I think you may use some different approach and you would have some other detail. But I think I gave you the general idea that you want to create some way of classifying, and it's not identical classification, but you use one classifier to train the other one. Right. You can also use transfer learning. And again, maybe I shouldn't go into too much detail because this is your part to discover some approaches to do this. The important thing for you is to understand what the problem is. Okay. So I just briefly can say that in transfer learning, I can give another example. Suppose you have a classifier that can classify cats. And you want to instead to classify, you want to, suppose you have a model like this, classify text very well. And you want to use the same model to classify dogs. So what you want to do is take most of the model from cats and then adjust it to use it for dogs. I mean, because cats and dogs have a lot of similarity. They have more similarities than differences, right? They all have, both have a nose, they both have 4 legs, they both have fur, they're very different. But the distinguishing features are maybe you can look at the same thing and distinguish. But I mean, you have certain kinds of cats that are very small and long, and you have certain kinds of dogs that are very small and long, right? So what you want to do is take your cat classifier and change a few things about it and adjust it to make it work for dogs. That's called transfer learning, and you can look it up. Okay, that's a very common thing. Now, if you look at the notebooks, maybe we can look at those tomorrow morning because I think my time is up. You will find that the classifier that I found, the accuracy is not so good. It's really not so good. However, if you look at the results, let me just do a result with 2 classes. So here's my name again. If you look at the results, you may see something like this. And something like this. This is just one example. Okay, not a very good example. So what you see maybe is a lot of green pixels with a few red. And then you see a lot of red pixels with a few green. Now, actually, the way buildings are built, typically it's large neighborhoods are all built together. Right? Large neighborhoods are all together. So it's quite likely that these red are misclassification. So that's something to think about. That perhaps after you do a preliminary classification, you can look at the location and do a reclassification. That's something you can think about. And I think I'm done. I am done. So don't get confused. That's I think the questions are very helpful. Think about what people are asking and this idea. I think also this example of dogs and cats would be helpful. That you have something that works very well for one type of object, and you want to reuse that quickly to classify some other type of object. Okay. So please read the notebook tonight, and I think tomorrow morning we'll have another Q&A. And after you've read the notebooks, we can go through the notebooks and you can see how that works. Okay. Well, thank you.
So, from your left.
Yes.
Right. So what I suggest,
Sorry, I need to read this again.
go through the notebook yourself today, like don't concern yourself with the virtual machine and logging in and stuff. We'll tackle that tomorrow. You know, when we send you the links based on which team you're in. And I think go through it today, and then tomorrow for the first hour we'll have more Q&A. Right, once you've gone through it, just to make sure that before you go, that you're going off in the right direction, you know. So that's what I suggest. So luckily we don't have to wait till 6. The transport's already on its way, and we will be taking everyone to a place nearby, an observatory, where it's like a mall type situation, and you can get stuff to eat. And then after a while, it will. I think at 7 or something we can, because it was 7:30 originally, right? Yeah. Well, that's probably too late once we're going early, so we can tell them. Yeah, we'll communicate with them. Then bring it earlier, and then we can head back to the hotel. Okay. Thank you for the first day.
I was wondering how you guys are using the data, because I know my honors project is like a huge challenge with data.
Yeah, in fact, there's, I think, I'm not sure if they shared it, but there's a.
This is for interesting.
The notebooks.
Okay, I'll check, but I think we only have the notebooks, yeah.
I mean,
Okay. It's a question.
yeah, okay. Wait, which are separated? Yes.
Are we?
So if I circle that, yeah, but basically give it information about. Classifying.
We can make some notes if you want to talk about it.
Have information about the ears, information about the nose. Using all of that information together to classify the dog. So we're going to use the red, the infrared, some of the data. We're going to use all that information to try to classify the age of the dog. Yes. Data was clean. Oh, you can assume that these pictures were taken under the same conditions. I don't think the temperature affects much. Well, actually, it may affect the spectrum. Yeah, but it probably will affect the spectrum. The temperature will don't. But that's part of this. The different from the. We hope that we know what characteristics to look at. Same characteristics will help us differentiate that are used to differentiate. Right, for instance, like I said, suppose the old buildings are tall and the new buildings are tall. Right? Suppose the other way around. Right? Now, if I know that, and I look at tall small buildings in Madrid, I classify one way. And they might classify another. So I'm taking my Madrid model and I'm modifying it to apply. But Madrid tells me I should look at tall small. Right? So that's what the Madrid model tells me. Look at tall small. And I look at tall small for instance, and it tells me it still helps me sell. Helps me different prices. Help me which price. So it's precisely. Yes, it is. They used to be a lot of others. Well, I think you can